2 and 7, basically your alkali earth and halogens. Group, 11.1 is group 2. You can see here the alkali earth metals have all 2 electrons in their outer shell, 2, 3, 4, 5, and 6, and it's a full subshell of the S, meaning that the ionization energy is larger compared to the alkali metals and to the aluminum group 3. Obviously, as you go down the periodic table, the size is increasing because of different energy levels. It goes through 2, 3, 4, 5, and 6, and then radium 7. Melting point is typically going down. There is a dip with magnesium. That's a special property for magnesium because of the specific size it is. But generally they go down. Density generally go up, typically because of the mass to volume ratio is increasing. Even though the volume is increasing a little bit because of energy levels, the mass is significantly getting bigger as you go down. The reason why it dips from beryllium and calcium is because the mass is insignificant compared to its volume change. So the volume is increasing at a greater ratio than the mass comparatively between beryllium, magnesium, and calcium. But since you get into the d orbitals after calcium, the mass is getting larger. Alright, reactions. Alright, so they form ionic compounds. Obviously, they lose 2 electrons in the outer shell, creates a 2+ ion. For example, magnesium loses 2 electrons. Therefore, they are oxidized, Leo, and they are reducing agents. Reactivity increases when you go down. That is because of the radius. The ionization energy, you can see, is going down, so it's easier to ionize from beryllium to barium. See a big jump from 1 to 2 because it is tougher to remove that extra electron from an ion. But again, they all decrease as you go down. Reaction with oxygen, this is kind of review from last chapter, but a metal plus oxygen makes a metal oxide. If you react that to water, you make a base. So for example, magnesium to oxygen makes MgO. If you were to put MgO in water, you would make a hydroxide, in this case magnesium hydroxide. Like any other metal, they have different colors. Flame test shows calcium is a brick red, strontium is scarlet red, barium is a greenish yellow, almost like a golden apple color. Reason why is when they get excited, electrons jump energy levels, and then not enough energy to hold that electron, so it has to fall back down, releasing light. Alright, summary. Metal plus oxygen makes a metal oxide. Metal and water makes the metal hydroxide plus hydrogen. As you go down, the increased reactivity. And then a metal oxide plus water also makes a metal hydroxide, but no hydrogen gas. Alright, 11.3, thermal decomposition of carbonates and nitrates. All carbonate reactions, if they are decomposed, makes CO2, and then all nitrate solids release nitrogen oxide, NO or NO2. As the elements go down the periodic table, more energy is needed to decompose the solid. That is because there are stronger ionic bond between the ions of metals. So as you go down, there's a stronger ionic bond with comparative calcium compared to magnesium. Alright, here are 4 homework questions for group sections 1.1 to 1.3. Um, what is the general trend of melting points going down group 2 and why? Predict radium's melting point density and metallic radius. Write a balanced chemical reaction including states for the reaction of strontium and oxygen and barium oxide with liquid water. And which of the following compounds listed will decompose at the lowest temperature, and explain why.